In this video, we'll be finding the area of a region with respect to y. To find the area between two curves with respect to y, find the area of the right curve and subtract the area of the left curve. The problem that we'll be working on is to determine the area of the region enclosed by the graphs of x equals 1/2 y squared minus 3 and y equals x minus 1. Now I've sketched a graph of this curve. This equation right here is a good indication that we'll be finding the region with respect to y. Let me show you what needed to be done to get the graph of this curve. We first needed to solve this for y, so adding 3 to both sides gives us x plus 3 equals 1/2 y squared. And then multiply both sides by 2. We have 2 times the quantity x plus 3 is equal to y squared. And then square rooting both sides gives us y is equal to plus or minus the square root of 2 times the quantity x plus 3. So we can see that our graph is going to be the positive square root curve and the negative square root curve. Also, when x is equal to -3, we have an x-intercept. So our positive curve is this one right here, and then our negative curve is the reflection across the x-axis. And then, of course, this one is the linear function that has a y-intercept of -1 and a slope of 1. So that's this line right here. So we want to first find the points of intersection of the two graphs. So we want to solve the system x equals 1/2 y squared minus 3, and this equation would be x equals y plus 1. We can solve this with substitution. So we have 1/2 y squared minus 3 is equal to y plus 1. I'm going to multiply both sides by 2 to get rid of this fraction. So y squared minus 6 is equal to 2y plus 2. Now we can move everything to one side and look at the quadratic. Y squared minus 2y minus 8 is equal to 0. And this quadratic factors to y minus 4 times y plus 2 equals 0. We can set each of these equal to 0, so this one gives us y equals 4, and this one gives us y equals -2. So our lower bound here is -2, right here, and then our upper bound is y equals 4. So since we're finding the area with respect to y, we're going to use this representative rectangle. Which has a width of dy, and we're going to move it from -2 up to 4. So the integral from -2 to 4, and whenever you do the with respect to y, you need to take the right curve and subtract the left curve. So our right curve is the linear function, which is y plus 1, minus the left curve, which is 1/2 y squared minus 3. And that's with respect to y. Let me simplify this expression a little bit. So by, this minus gets distributed. So minus 1/2 y squared plus 4. When we integrate this, this is y squared over 2. This one is y cubed over 3. And then this one is 4y, from -2 to 4. So we'll sub in 4 first, and we have 4 squared over 2 minus 4 cubed over 6 plus 4 times 4. And then we'll subtract from that when we sub in -2. This gives us 16 divided by 2, and 64 divided by 6 plus 16. This one is 4 divided by 2, and then -8 divided by 6, and then -8. When we do the math here, we get 18.